typical example for it. But first of all, I'll take my time and we see the condition behind the first law of thermodynamics. Now, for the first law of thermodynamics, it says that the change, okay, so we have the rule of del U, which is equal to the sum of partial Q minus the summation of the what of the partial W over here. Now with this condition, one thing that you need to keep in mind is that anytime you have your Q here, means your Q total, then your W total. So you can have this written as change in U to be equal to Q here minus our W here too as well. This change in U is the same as U2 minus U1 here. Now what about the Q here? Now the Q here is equal to the QE minus Q out. Then the W here means the W out minus the WE here. Why so? Now for instance, you see, we can have this as our steam power plant over here. So for instance, something like this, we have another one to here like this. So from this to this to this and lastly to this. So this being our boiler, this one being our turbine, this one being our condenser, and this one being our pump here. So from here straight, this is where it takes the water from this side, so that becomes the work in here. Then as it comes to the boiler, it heats up to a certain energy. So that means once it heats up over here, here becomes our QE. Then here is where the fluid will come here and the work will be done at this point over here. Alright, so let me use this one here. So this one is where our torque is coming from. So this one is our turbine. We are also having our work out here. And lastly, we are having our condenser to reject the heat as well as Q out over here. So you can have Q8 minus Q out. That means this one here minus this will give us the Q total. Then the W here to here, we having our what? We having our W out here. That is W out minus the W in here. This is the work in and the result of the work out here. So anytime you are given a question, make sure you take your time to analyze it. Now when you talk about compression, compression means it's negative. Alright, as we talk about the same thing related to the piston. So in case you have something like this, so that means anytime we have this here, the arrow coming here, this is where we have the what? We have the work in here. Then anytime we have a piston to here as well, then it is moving out like this one here. Alright, so that means this is now coming out. So this is where we have our work out here. So this is the work done on the system, okay, by the surrounding is the working. Then the work out is the work done by the system over here to the surrounding here too as well. So anytime a problem is being given, you use this to analyze it very carefully. So now let's start. And for the question says that an air compressor which compresses air at a constant internal energy rejects a heat of 80 kilojoules of heat, right, to the cycling water for every kilogram of air. Calculate the work done during compression stroke per kilogram of air. So first of all, you ask yourself, what is the question trying to say? So if we are having an air compressor which compresses an air at constant internal energy, so that means at this point here, the internal energy here is constant. So you can have change, okay, so you have change in what? Change in U is equal to, right, is equal to 0. because at this point here it is constant. The internal energy here is constant here. Then it rejects the heat of what? Of 80. So now if we have our Q here and it rejects the heat, so that means that we say the Q is 80 kg here. So let's see how. So you know that our Q is equal to our Q8 minus our Q out here. So with this one here, we can have this one to be our negative. Then we can also have our out here. So the out here was in what? Was in 80 kilojoules. So we have our 80 here, that is kilojoules over here to us. So that means our Q total is what? Is negative 80 kilojoules. And lastly, were we given the work? No, we weren't given any work here. So we don't know. So how do you calculate it? So you know that our change in U is equal to our Q minus what? Our W here. So we know that from this we have our change in U to be equal to. So what is our Q? So now we know that our Q is equal to negative 80 here, right? And minus, what is our W? Our W is the one that you're supposed to find for. So we know that our change in U is now equal to 0 to be equal to negative 80 here minus W here. So now you can see that we can now bring our work here. We have our work to be equal to negative 80 and add the kilojoules then what? 80. So that means if we have negative here, indicate that it was a what? It was compressing it, right? So if it is compressing, that means it's what? It's working. Because once we have working here, it's compressing it. So you can see compressing. Alright. But once we have the workout here, you can see that there is what? There is an expansion over here. Thank you very much for watching.